Okay, so we're talking about the postnatal. We've already covered some of these pieces, but I'm just running through. Lots of structural and physiological changes. One of the questions that was on your study guide, right? Describing major cardiovascular and other physiological changes in the newborn. So here are some of those pieces. The mother starts, of course, producing milk, right? This prolactin is no longer inhibited. Pro means in favor of. Lactin means milk, right? So this is the hormone that helps milk come. Does that make sense? And so the mammary glands start producing these large quantities of milk. And the very first milk we've talked about, called the colostrum, has tons of antibodies. It's a very liquidy, almost waterish, very, very thin fluid. My wife would say one of the biggest surprises she had was the difficulty sometimes with both of our kids of getting them to breastfeed. And she never thought that this might actually be a difficult thing. It's just supposed to be something you're supposed to naturally do, right? And so she felt horrible that she could not, for whatever reason, they both didn't want to initially breastfeed well. They both figured it out. It was just a matter of finding the right process. They have these sucking reflexes that as soon as that nipple gets close, they turn to it and start sucking. And this is just what the baby is born with to help with this feeding. But that was one of the things I remember her saying very clearly was, I never expected there would be any trouble with this, but it happens consistently. And you just work through it. You keep trying. You keep working at it. Do you have a question, someone, or no? Okay, moving on. And again, they talked about it really is the best food possible for the babies. And of course, the more you feed, the more milk comes, right? If you slow down the feeding, then the milk production slows down as well. They are intricately related. We talked about surfactant in the lungs, and the video does a nice job of talking about that piece. And that's why you heard that first cry of the baby was very gurgly, right? Because again, the lungs are filled with fluid, and that has to all come out now, right? And then they cry, and crying is good because it's telling us, okay, this baby's lungs are working, they're breathing. Does that make sense? That is a significant problem, right? That means they're not breathing. Yeah. Because they're not just going to come out and just sit there, oh, what a nice place this is. No. They were thrust into this horrible new world, right? Yeah. If for some reason it's not, sure, they might do some things to stimulate it. But again, normally the reaction you see, the baby starts crying pretty immediately. They get not really shaking, but again, they're trying to drain this fluid out. Sure, yes. We tend to encourage you not to shake babies. It does very bad things to them, but yes. There is some time between the mother being able to get the full amount of milk that she would produce and the baby being born, again, as these hormones ramp up. So sometimes it takes a couple of days for you to really get the milk coming in. This is how they phrase it, and my wife will talk about this, remembering this very clearly, that suddenly just felt engorged, like, oh my goodness, I need to have the baby feed now. And sure enough, that's when the milk had dropped or come in. They talk about the kidneys, again, making sure they stay hydrated. The circulation pieces, of course, there's a whole diagram that shows the different pieces. Remember all those little extra veins and holes in the heart? All those things have to, number one, either shrivel up if it's the vessels from the umbilical cord, or number two, actually close to allow the regular circulation to happen. And again, why? What's the big point behind that fetal circulation versus a newborn circulation? The fetal circulation, the blood doesn't have to go to the lungs, right? Because the baby's not breathing. It's getting all the oxygen from the mother. Whereas as a newborn, please, you need blood to go to lungs, right? And so all of these different pathways that change are simply a way to allow that normal circulation that we learned back in the circulatory system. No, that's all from the milk. It's a good question. I don't remember. We could look it up, but I don't remember off the top of my head. Yeah, because normally they're eating frequently enough to not have to deal with needing more fluids that way. Okay, genetics. Briefly, there's not much here in this PowerPoint about genetics. There were 4 or 5 questions that were in your study guide here about genetics, being able to understand the different pieces that are there. So let's first talk about autosomes and sex chromosomes. So again, genetics is dealing with inheritance, right? What Mrs. Serrano was describing with her son is inherited traits, right? Because of course you get genes from your mom, genes from your dad, and it's the combination of those two that are expressed in you. What color your hair is, what color your eyes are, what color your skin is, how tall you are, etc., etc., etc. Those are all just physical characteristics. We can also talk about your health, right? Are you more prone to heart disease or diabetes or lung disease? Based, again, upon your genetics. And if there's a mutation, that means there's a change, right? So maybe you didn't get the exact perfect copy from your mom. Maybe there was a small mutation on one of the genes, and that can cause other difficulties.
When people have like the hole in the septum of the heart or whatever, is that because the foramen or valve or whatever didn't close?
Often, you're correct. Yep, definitely. And that's this guy up here, right up here. Again, that's between the 2 atrium. Yep. So if that doesn't close over the period of the first couple of weeks, they'll do surgery to do that, because that is a significant issue. All right, let's continue on here. So you've got, of course, chromosomes coming in pairs, right? And you've got these karyotype charts that show the 23 chromosomes. They look like this, right? All the different sizes and shapes to them. And again, each of these sections deals with a specific something. This was a huge thing back in the early 90s when we decoded the genetic code. For the first time, they could tell you exactly, remember, G, C, A, T, right? All this all the way down. They could tell you the exact code for a human, which is just unbelievable to me. Billions and billions of these pairs, and we know the code, which is cool, but all right, and what do we do with that? Now we try and say, okay, what genes are dealing with what diseases, or what characteristics, or what problems, or what anything? And that's what the last 20 years we've been doing, is trying to find these specific pieces. Oh, CRISPR is fine, it's just a technique. What you do with it, of course, that's a whole other question. But yeah, a lot of the genetic, they just won a Nobel Prize this last year for the CRISPR technique because it's so powerful. You can edit and change and move things around, and we can do awfully good things with it, but you can also do awfully poor things as well. It's just so much volume. It's so many places. So easy, I would say yes, but there's just so much data. And as we'll see, rarely is it one little gene that controls this specific something. Many things are multifactorial.
I was doing a little research into it.
Yeah.
And so they can go in and like check like individual genes and stuff. But then like the total volume of genes in general, like what you're talking about, is if you were to get like pieces of paper and like print out like with just regular 12-point font and then type out all the different sequences, you would have enough volumes of encyclopedias to line them up against that row, like essentially from that side of the room to the side of the room, just the other encyclopedias.
Does that make sense? Completely printed on both sides, front and back. I mean, it's a ton of information. So yeah, we can do some isolating. And again, these folks spend 20 years of their career focusing on one gene type, one section of those genes to deal with a specific disease or a specific trait or something like that. Yeah. It's good. Thank you, Rick. That's good. Autosomes, these are the chromosomes 1 to 22 that carry genes. They've got the genetic material, but they don't determine sex. Those come from the sex chromosomes, right? The 23rd pair, which is the X and the Y. That's these little guys down here. Excuse me. Modes of inheritance. So the patterns of how we inherit characteristics, that's what we call these modes of inheritance. And there are 3 major ones: autosomal recessive, autosomal dominant, and X-linked recessive. So let's talk a bit about this because they don't really show anything here about that. If you go in your textbook over to page 572, this is what we're talking about. So we've got a picture like this. They're talking specifically in this picture about cystic fibrosis, a lung disease. Okay? And what you see is that both of these parents have the trait, that's the blue fiber, the blue allele, that would produce cystic fibrosis, but they don't actually have cystic fibrosis. This is a recessive gene. Are you with me? Again, you all have heard this before, so I'm kind of just glossing over the pieces. But when they have kids, are you comfortable that there are three options? Number one, both their kids can get both of the non-cystic fibrosis alleles, and they would be unaffected, right? That would be this white baby. They can end up the same way as the parents, with one non-cystic fibrosis allele and one cystic fibrosis allele, right? And that actually, that's a 50% chance of that happening. Because again, you remember the Punnett squares, right? That this goes with this and this goes with that to make two pluses, a plus and a cystic fibrosis, a plus and a cystic fibrosis, and two cystic fibrosis, right? So this would be, they would be able to transmit that cystic fibrosis gene to their kids, but they wouldn't have it. Does that make sense? They'd be just like the parents. And then last but not least, you could get both of those cystic fibrosis alleles that come together in that gene, and then that baby would have cystic fibrosis. No, the only way would be as if you married somebody else who has a cystic fibrosis gene. Then your kid would not be able to, right? Because they only would get one of the white ones from you, right? But then their kid could, if they had a baby, and then have another mate with cystic fibrosis gene. Does that make sense? Okay? So again, this is autosomal recessive. This is a type of gene that we're dealing with here with cystic fibrosis, that autosomal recessive. Autosomal dominant, right? Oh, sorry, I lost my spot here. My apologies. Yes, autosomal dominant, right? So this would be if it is displayed at all. So let's go back to this. If it's displayed at all, that baby would have the trait. Does that make sense? You don't need two of them to make it work. The recessives, you need two to make it work. Autosomal dominant means if I have one of them, it's dominant, it will produce that problem. Does that make sense? Excuse me. And the last piece they talked about was the X-linked recessive. And the point of that, it works the same way as the recessive gene we just talked about, the autosomal recessive, but it's just only contained on the X chromosome, that 23rd chromosome. Does that make sense? Autosomal dominant, things like Huntington disease, that is a disease that deals with that. Loss of coordination, uncontrollable dance-like movements, cognitive impairment, etc. Autosomal dominant, right? This is the name of the disease. Punnett squares and pedigree charts, that's what these things are, right? You've seen something like this before. So could you read that? Like if I gave you something like this, could you read it and tell us what we're expecting, right? That this person would have no characteristics, this person would, and these guys would just be carriers if this was, again, autosomal recessive. Yeah, I'm pretty sure. It is in mine, page 572. Is it not in yours? Yeah, page 572. And here they're just showing, they only had 3 kids, right? One did not have it, one was carrying the recessive gene, and one got the 2 pieces, and so they are carrying it. They are expressing it, not carrying it. They're expressing that trait. I think these pictures are quite interesting that they show you there on page 573. They're showing you about multifactorial traits or multi-gene traits that are not covered by just simply one something. And if everything was just by one gene, our life would be so much easier to do the research, right? Oh, let's turn off this one gene and you're fixed. But no, so many things are many different genes that play a role, as well as environmental factors as well. So this is showing height. If you didn't read the caption here, the first picture is from taken around 1920, and it's showing 175 cadets at the Connecticut Agricultural College, and they're lined up by height. And what's interesting is this tallest person here, did you see what height they are? 5'9". Right? And then if you look at the picture that was taken in 1997, the genetics class, same university, they lined up everybody. And what do you notice? Significantly taller, 6'5", right? We're talking about 8 inches in difference in height. 5'9" is right here, right? I mean, just about right in the middle of the size. And please give me 2 minutes. Why would that be? One of the biggest things they attribute this to is simply nutrition. We eat so much better than our ancestors did. When I say ancestors, I mean just a couple of generations ago. You know, rarely, and again, in our country, do you have significant nutritional deficits. In other words, you're not getting enough calories. We have problems because we eat too many calories. Are we cool? Again, please, just 1 more minute. I apologize. So that is the last piece, is to deal with polygenic means multi-genes, right? And multifactorial means it's genes, yes, but it's also environmental pieces and other factors that contribute to whether or not you express that gene. Whew. Thanks for bearing with me as we zip through. Adios. Thank you.